Dark energy is accelerating the universe right now. Every second, space itself expands faster, pushing galaxies away from each other at speeds that shouldn't be possible. Scientists discovered this in 1998, and it changed everything we thought we knew about reality. But here's what makes this terrifying. We have absolutely no idea what dark energy actually is. We can measure its effects. We can see what it's doing to the cosmos. We can track its influence across billions of light years. But the force that makes up 70% of everything that exists remains completely unknown. And the worst part, it might not stay constant forever. People assume dark energy is just another mystery science will eventually solve, like black holes or quantum mechanics, something complex but ultimately explainable. Give it time, throw enough money at telescopes, and we'll crack the code. That's not what's happening here. Dark energy breaks the fundamental rules. It violates our understanding of physics in ways that make physicists genuinely uncomfortable. When you dig into what we actually know about this force, you realize we're not dealing with a puzzle missing a few pieces. We're looking at something that might be fundamentally unknowable, something that operates outside human comprehension, and it controls the fate of everything. The story begins with Einstein. In 1917, he added something called the cosmological constant to his equations, a fudge factor. He needed the universe to stay still, because that's what everyone believed back then, a static cosmos. But his own math kept telling him the universe should either expand or collapse. So he invented this constant, an anti-gravity force built into space itself. Years later, when Edwin Hubble proved the universe was expanding, Einstein called it his biggest blunder. He removed the constant. Everyone forgot about it. The cosmological constant became a footnote in physics history. Until 1998, two independent teams of astronomers were studying distant supernovae, Type 1a supernovae, specifically. These exploding stars are so consistent in their brightness that they work like cosmic rulers. You can measure exact distances across the universe using their light. Both teams expected to find that the universe's expansion was slowing down. Gravity should pull everything back together over time. The Big Bang sent matter flying outward, but gravity acts like a brake. That's what made sense. That's what decades of cosmology assumed. Instead, they found the opposite. The universe isn't slowing down. It's speeding up. Galaxies are accelerating away from each other faster and faster. Something is pushing against gravity itself. Something is overpowering the attractive force of all the matter in existence. They called it dark energy, the most honest name in physics. Dark because we can't see it. Energy because we have no idea what else to call it. Think about what this means for a moment. 70% of the universe is made of something we've never detected, never isolated, never understood. The observable universe contains roughly 2 trillion galaxies. All the stars, planets, black holes, dust, and matter we can see makes up less than 5% of what actually exists. Another 25% is dark matter, which at least interacts with gravity. We can map dark matter by watching how it bends light. But dark energy? It doesn't interact with anything except space itself. You can't touch it, can't measure it directly, can't even prove it exists except by watching galaxies move. It's a placeholder, a name for our confusion, a reminder that we barely understand the universe we inhabit. Here's what makes cosmologists lose sleep at night. Dark energy has a density, roughly 6 times 10 to the negative 10 joules per cubic meter. That's unimaginably small. So small it took decades of precise measurements across the entire cosmos to even detect its presence. But here's the devastating problem. Quantum field theory predicts the vacuum energy of space should be 10 to the power of 120 times larger than what we observe. That's not a small error. That's the worst prediction in the history of physics, off by 120 orders of magnitude. Either quantum mechanics is catastrophically wrong about the fundamental nature of empty space, or something is canceling out almost all of that energy with impossible precision. We don't know which. We don't know how. We just know the numbers don't work. The math breaks. Reality refuses to cooperate. The universe doesn't care about your comfort. Dark energy does exactly one thing. It makes space expand, not objects moving through space, space itself growing. Every cubic meter of the universe generates more cubic meters, exponentially, forever. Right now, galaxies beyond a certain distance are already moving away from us faster than light, not because they're traveling through space at superluminal speeds, but because new space is being created between us and them. And that boundary, called the cosmic event horizon, gets closer every year. Eventually, every galaxy outside our local cluster will cross that threshold. Their light will never reach us again. They won't be destroyed. They'll just become unreachable, forever separated by an expanding ocean of space, erased from our sky. What does the far future look like? If dark energy stays constant, we get the big freeze. In 100 trillion years, the last stars burn out. The universe becomes a cold, dark ocean of scattered radiation and dead matter. Galaxies drift apart until they can't see each other anymore. Eventually, even protons decay. Everything dissolves into scattered photons and isolated black holes. And those black holes, they evaporate through Hawking radiation over timescales so long that the current age of the universe is a rounding error. 10 to the power of 100 years, 10 to the power of 1,000, numbers that have no human meaning. True heat death. The universe approaches absolute zero, eternal darkness. Nothing can ever happen again. No stars, no planets, no light, no change, just infinite emptiness, forever. That's if dark energy stays constant. That's the optimistic scenario. But here's the twist that keeps physicists awake at night. What if dark energy isn't constant? What if it's changing? What if it's getting stronger? Some theoretical models suggest dark energy could strengthen over time. The repulsive force could grow. If that happens, we get something called the Big Rip. The acceleration doesn't just continue, it intensifies. In 20 billion years, dark energy becomes so powerful, it overwhelms gravity inside galaxy clusters. Galaxies tear apart. In 60 million years before the end, the solar system disintegrates. Stars get ripped from their planets. In 3 months before zero, dark energy grows strong enough to overcome molecular bonds. Planets explode. In the final minutes, dark energy tears apart every solid object. In the last fractions of a second, atoms themselves get shredded. Every structure in the universe, from galaxy superclusters down to individual nuclei, gets torn apart in a cascade of cosmic destruction. Everything ends at once. The universe doesn't fade, it shatters. The real horror isn't the Big Rip itself. It's that we have absolutely no way to know if it's coming. Dark energy could shift tomorrow, next week. It could stay constant for trillions of years and then change instantly. We can't predict its behavior because we don't understand what it fundamentally is. Every model is speculation. Some physicists think it's the energy of the quantum vacuum. Others suggest it's a new field permeating all of space. Some think it's a sign that general relativity breaks down at cosmic scales. Others wonder if it's an illusion caused by how we measure distances. And here's the most disturbing possibility. What if dark energy is just the universe's default state? What if expansion is built into reality itself and there's no deeper explanation? What if we're asking why questions about something that simply is? What if reality itself is intrinsically incomprehensible? We're living in a universe where the dominant force is invisible, unmeasurable, and potentially unstable, where 70% of reality operates by rules we haven't discovered and might never discover, where the fate of every galaxy, star, and planet depends on the behavior of something we can't even properly define. Scientists build billion-dollar telescopes to study dark energy more precisely. They map millions of galaxies looking for patterns in acceleration rates. They run simulations exploring thousands of theoretical models. They measure the cosmic microwave background to unprecedented accuracy. And after decades of intensive research involving thousands of scientists, our best description remains exactly the same 2 words: dark energy. A label for our ignorance, a placeholder for what we cannot grasp, a reminder that the universe doesn't owe us understanding. This isn't like other scientific mysteries. When we discovered DNA, we knew we'd found the right answer. When we split the atom, the math worked. When we detected gravitational waves, they matched Einstein's predictions exactly. But dark energy, the more we study it, the less sense it makes. Every new measurement confirms it exists and confirms we don't understand it. Every theoretical attempt to explain its nature fails. We're not converging on a solution. We're documenting our confusion with increasing precision, building better instruments to measure something we can't explain. That's what makes it the biggest mystery in the universe. Not because it's complicated, not because we lack data, because it might be genuinely incomprehensible to minds operating within human physics. The universe is expanding, accelerating, driven by a mysterious force that dominates everything and explains nothing. And we're just along for the ride, watching galaxies disappear across an expanding horizon we can never cross, measuring numbers that refuse to add up, building theories that don't quite work, hoping someday we'll understand why existence itself seems designed to remain forever beyond our grasp. That's the reality we inhabit, a cosmos controlled by darkness, governed by forces we cannot see or comprehend. And there's nothing we can do except watch and wonder, and measure the rate at which understanding slips further from our reach. Thank you for watching. If you want to go deeper into this topic, you might enjoy the next video. I'd be very grateful for your support, and I'll see you next time.